Lesson 25, Indirect Proof and Inequalities in One Triangle. The objectives and vocabulary of the lesson are to write indirect proofs, apply inequalities in one triangle, and your vocabulary for this lesson is indirect proof. So far we've written proofs using direct reasoning. We start with a true hypothesis and we build a logical argument to show that the conclusion is also true. With an indirect proof, we begin by assuming the conclusion is false. Then we show that this assumption leads to a contradiction. This type of proof is also called proof by contradiction. So the steps for an indirect proof are, first of all, you want to identify the conjecture to be proven. Number two, you would assume the opposite or the negation of that conclusion. 3, you use direct reasoning to show that the assumption leads to a contradiction. And number 4, you'll conclude that since the assumption is false, the original conjecture must be true. Something to remember is that when writing an indirect proof, we want to look for a contradiction of one of the following: the given information, a definition, a postulate, or a theorem. For example 1, we want to write an indirect proof. We want to show that if a is greater than 0, then 1 over a is also greater than 0. So let's follow the steps. In step 1, we're going to identify what we wanted to prove. We were given a is greater than 0. We want to prove that 1 over a is greater than 0. Well, step 2 told us to assume the opposite of the conclusion. So let's assume 1 over a is less than or equal to 0. So now, step 3, we say use direct reasoning to lead to a contradiction. So we start with the given, which is our opposite of our conclusion. We have a is greater than 0, that was given, and 1 over a is less than or equal to 0, and that's the opposite of our conclusion. The zero property of multiplication and property of inequality lets us say that a times 1 over a is then less than or equal to 0 times a. If we simplify, we get 1 is less than or equal to 0. However, we know that 1 is greater than 0. So this helps us conclude the original conjecture is true. The assumption that 1 over a is less than or equal to 0 is false. Therefore, 1 over a is greater than 0. The positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. We have 2 theorems that help us decide which sides should be the longest. 551 states, if 2 sides of a triangle are not congruent, then the larger angle is opposite the longer side. So the bigger the angle, the longer the side. 552 states, if 2 angles of a triangle are not congruent, then the longer side is opposite the larger angle. We can clearly see that XY is opposite the largest angle Z in this triangle. Let's look at an example. We want to write the angles in order from smallest to largest. And we're given the sides of this triangle. The shortest side, GH, so the smallest angle is opposite, straight across, and that would be F. The longest side is FH. So the largest angle is G. This tells us that the order from smallest to largest would be angle F, angle H, and angle G. If we want to write the sides in order from shortest to longest, and we are given a triangle with two angles identified, we want to find the measure of the remaining angles, so we subtract from 180 and we get that angle R is 48 degrees. The smallest angle is R, so the shortest side is PQ. The largest angle is Q, so the longest side is PR. If we want to order them from shortest to longest, we say PQ, QR, and PR. A triangle is formed by three segments, but not every set of three segments can form a triangle. The segment with lengths 7, 4, and 4 can form a triangle, but the segments with lengths 7, 3, and 3 cannot. If you notice, because of the angles, they are not going to ever reach in the center to form that triangle. A certain relationship must exist among the lengths of the three segments in order for them to form a triangle. Theorem 553, the triangle inequality theorem, states the sum of any two lengths of a triangle is greater than the third side length. So AB plus BC has to be greater than AC. BC plus AC must be greater than AB. AC plus AB has to be bigger than BC. Let's look at an example. Tell whether a triangle can have the sides with the given lengths and explain. So we have 7, 10, and 19. Well, 7 plus 10, is this greater than 19? No, 17 is less than 19. So no, by the triangle inequality theorem, a triangle cannot have these side lengths. What if it's 2.3, 3.1, and 4.6? 2.3 and 3.1 equals 5.4, and this is greater than 4.6. So it works for those two. 2.3 and 4.6 is greater than 3.1, so it works. 3.1 plus 4.6, which is 7.7, is greater than 2.3. Since the sum of each pair of lengths is greater than the third length, these would form a triangle. Let's apply the triangle inequality theorem when we have expressions and when we know the variable value. We have n plus 6, n squared minus 1, and 3n when n is 4. So we need to plug in 4 and try these out. So n plus 6 is 4 plus 6, which is 10. N squared minus 1 would be 15. 3n is 3 times 4, which is 12. Let's compare the lengths. 10 plus 15 is 25, which is greater than 12, so that works. 10 plus 12 is greater than 15, and 15 plus 12 is greater than 10. So yes, the sum of each pair of the lengths is greater than the third length. Example 4. The lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. Let x represent the length of the third side. Then we're going to apply the triangle inequality theorem. So x plus 8 has to be greater than 13. In this case, x has to be greater than 5. X plus 13 must be greater than 8. X has to be greater than negative 5. X plus 13, or 8 plus 13 is greater than x, so x is less than 21. Let's combine the inequalities, so 5 is less than x, which is less than 21. The length of the third side is greater than 5 inches and less than 21 inches. Let's use this idea for a travel application. The figure shows the approximate distance between the cities in California. What is the range of distances from San Francisco to Oakland? Well, let's let x be the distance from San Francisco to Oakland. Then x plus 46 is greater than 51. So x is greater than 5. We're using the triangle inequality theorem, and then we're the subtraction property of inequalities. Then we say x plus 51 is greater than 46. That means that x has to be greater than negative 5. And 46 plus 51 is greater than x. So 97 is greater than x. We combine the inequalities and we get 5 is less than x, which is less than 97. The distance from San Francisco to Oakland is greater than 5 miles and less than 97 miles. Now you try. Two more. And one more page for 7 and 8 with triangle lengths. Happy solving, and I'll see you next class.